Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Winelect, and today we're going to be looking at how you can use Azure to help find cures for diseases such as coronavirus or COVID-19. These animations simulate the effects of social distancing and other models for trying to contain a virus. The virus itself spreads more rapidly whenever you have many people in motion, such as going about your daily lives, going to work, going to school, going to wherever it might be. But social distancing, as we can see, has the best effect on preventing the spread of the virus rapidly. And the point of doing this is to slow the effects of the virus in a population so that it won't affect the long-term health of the community and won't overwhelm the capacity of the available healthcare facilities. One thing you can do in addition to social distancing to help prevent the spread of disease is help find the cure for diseases by using a project called Folding at Home. This app is designed to use computer simulations to find cures for diseases by looking at proteins in a simulated environment, and it helps narrow the field so that researchers can then use the simulated proteins to actually build drugs and other treatments for diseases like cancer, Alzheimer's, or COVID-19 or things like that. And it's fairly easy to use. You simply just go to foldingathome.org and then click on Start Folding Now. And then you can get a client for your PC, be it Mac, Windows, or Linux, or even an Android client at this point. And then once you have it, you can click on the installer and download it for your platform and then install it. After you get done installing the app, you'll get a screen that looks like this in your web browser, and you can either fold anonymously or set up an identity. Basically, what an identity does is gives you the ability to get a passkey, and then it allows you to get credit for the work that your computer does. Otherwise, you don't have to. I mean, you can fold anonymously, as it says here, and that basically means that you don't register for an account. So if I've set up an identity, I can go get a passkey here, and what that's going to do is open up a new tab where I can send an email to myself using this form, and it will have in it a passkey. And once I have that passkey, then I can put it in here, put the name, it provides a team number if I'm part of a team, and a passkey. However, once I'm anonymous, I can fold as well, and I can simply just adjust the power to full, and it will start doing calculations on this machine. Now, if you have a GPU, it will show up another column here that says CPU and GPU, and that will show you the abilities that your computer has for doing this folding of proteins on your local box. The way that distributed computing works with projects like Folding at Home is you have a central server that has all of the work on it, and that work is on the server ready to be done. However, the server itself does not have the compute capacity to handle all of that work. So what it does is it delegates it to other computers around the globe. And as more computers come online, the compute resources to perform that work become even more available so that the work can be done on a distributed network of computers across the planet. So as more and more computers come online, the work capacity increases, and the ability to perform that work is all the more available across that global network. And one thing that you can do is do this at home, like we've just seen when we installed the client. But the other thing you could do is use something like Azure to install a virtual machine on a Azure Compute Cloud or Google Compute or AWS, it doesn't matter, where you have a virtual machine running there that can do the exact same thing that your computer at home can do. Projects like Folding at Home can take advantage of two different kinds of processing units available on computers. Every computer in the world has a central processing unit, and that is the general purpose processing unit on your computer that's responsible for most of the computations that your computer does. And most modern central processing units have an integrated GPU, which is a graphics processing unit that's responsible for the processing of graphics on your computer that get sent to your screen. Now, for projects like Folding at Home, the integrated GPU isn't very useful, but the central processing unit is. On some computers, you have what is called a discrete GPU, which is a separate unit from the CPU that is connected to the central processing unit, but it has its own memory and its own compute capacity, so it can be then connected to your monitor separately, and it's not a shared resource within the context of your CPU. This allows the GPU to operate independently of the CPU, and it's not bound to the CPU, and so it can have much better throughput and have a lot more computational power baked into that GPU. And a GPU can be used for things other than simply processing graphics. And this is why a project like Folding at Home can take advantage of both the CPU and the GPU. And in many cases, a GPU can have better parallelization than a CPU because it has a lot of cores in it. And the number of cores inside of a GPU are for doing things like integer calculations. It's a stripped down subset of what a full CPU can do, but it's still enough to do some basic calculations that can be done in massive parallelization that you wouldn't able to do with a CPU. And it's for this reason that many projects like Folding at Home prefer machines that have discrete GPUs on them. However, they will work on machines that don't and have an integrated GPU. Because of the demand for GPUs, Azure introduced the N-series virtual machines. Most VMs on Azure only have a CPU bound to them, which is fine for most general purpose computing. But for some workloads, it's better to have a GPU, and having the GPU available on a virtual machine on Azure allows you to spin up resources and utilize those resources until your job is finished, and then you can shut them down, and then you're only billed for the time that you actually use them. Now, these are useful for all kinds of tasks, as we mentioned, including things like Folding at Home, which can take advantage of both CPU and GPU resources on a machine. To do this on Azure, I've made it easy by creating an ARM template and a script that will install Fold at Home on an Azure VM. Now to do this, I can simply come down here to the README on my GitHub repo, which is the onemule/FAH client-azure-VM, and click on Deploy to Azure. And this will take me to the Azure portal where I can fill out this form with the parameters I need to deploy this to Azure. So I'm going to create a resource group, and I'm going to call it FAH Client 2 maybe, since I already have a virtual machine running on this particular subscription here. And I'm going to put this on this subscription. And then I'm going to give it a DNS name. I'm going to call it FAH Client 2. And I'm going to give it an admin username, which I'm going to call Blaze, and a password to log on to this virtual machine. And the need for the password is going to be used not only for SSH, but to log on to the portal, the web portal for the FAH client, as well as an advanced option, which I'll show you in a moment. Now, to populate this piece here, I'm going to go ahead and plug in my user information for my Fold at Home, including my passkey as well as my user. And I'm going to select a standard NV6 VM, but you can also choose the standard D series VMs that I have populated in this form as well. And these do not have the GPU bound to them, but they're less expensive, while these N series would have GPUs as a part of the VM, as well as a lot of CPU compute as well, but they're more expensive. So I'm going to choose the NV6. And then once I have that, I can click on purchase, and then that will start the deployment of this virtual machine to Azure. And once it validates, I will see a deployment in progress, and then I can wait a few minutes and come back whenever this deployment finishes. So here I've deployed my resource, and I'm going to go to my resource group where it's been deployed here, and I'm going to select the VM that it deployed to Azure, and then I'm going to click on this particular DNS name and copy it because I need this to connect to the Folding at Home on Azure. So I'm going to open up a new tab, and I'm going to go to HTTPS and paste in that name, and then this is going to take me to a page where I'm going to get a connection error because this is using a self-signed cert, but that's okay because I generated it. And I'm going to proceed to this, and I'm going to punch in my credentials that I supplied whenever I created this particular virtual machine, and then that's going to take me to the web console, which we've seen already. And this is going to show me what I have going on so far. So currently I don't have any workloads running on this because it's got to take a while to download those resources and then delegate them to this particular machine because it is brand new. But after a few minutes of running, and it's got a workload to run, it will start processing against that workload on this particular virtual machine. Now, if you want to connect to it from the Folding at Home advanced tools, or as they're called, you can do that as well by grabbing that same host name and then launching the advanced controls for whatever platform it is that you're running. Now, currently, I've got a couple of machines running on this already, and I have this one already that's on Azure that is running. I'm going to add another one by simply clicking on Add right here, and I'm going to plug in the host name right here, and then I'm going to type in the same password that I supplied for the client when I logged onto the web, and this will connect to the virtual machine on Azure, and it's going to show me the resources I have deployed there as well. And as you can see with the FAH controller, the advanced controls on the Fold at Home client, you can have multiple machines running. Currently, I have a set of 6 machines that are actually doing work. I have 4 at home, and then I have 2 on Azure now that I've just deployed, and these are going to be running these workloads to help hopefully find a cure for many different kinds of diseases, including coronavirus and COVID-19. So if you want to get a screensaver of this, you can simply right click on it and go to Protein Viewer, and this will give you a nice visualization. You can use this for a screensaver as well on your desktop or laptop, and this is what the original program Steady at Home that this was based on did, and so it was popular for a long time to have that as a screensaver. But now you can use Folding at Home and actually contribute to something like finding cures for diseases rather than finding aliens. If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.